Good evening, this is MD Islam. Today I'm going to present a presentation on the behavior of polymer confined geopolymer concrete columns under axial loading. Subject code is ENGG 955 engineering design method. My student ID is 7705 77773. As a greener alternative to traditional cement-based concrete, geopolymer concrete has attracted a lot of interest recently. Geopolymer concrete is created by activating aluminosilicate source material with alkaline activators, producing a hardened material with characteristics similar to conventional concrete. So numerous benefits of geopolymer concrete include reduced carbon emissions, then improved chemical resistance and increased compressive strength. The objective of this presentation is understanding the behavior and mechanical response of polymer confined geopolymer concrete column, and also how geopolymer and find out how geopolymer confined concrete behaves under various loading scenarios, and also to understand the mechanical reaction, load carrying capability and failure mode of column. Research question. So the behavior of geopolymer confined concrete columns under axial loading is the research subject that is being addressed. So understanding the effects of polymer confinement methods such as basalt fiber sheets or carbon fiber reinforced polymers on the mechanical characteristics, load deflection behavior, failure mechanism and stress-strain relationships of geopolymer concrete columns is the main goal of this study. Geopolymer concrete has gained a lot of interest recently as a more environmental friendly alternative to traditional cement-based concrete. So polymer confinement techniques hold promise for enhancing the performance and behavior of geopolymer concrete columns under axial loading. So now we are going to discuss some mechanical characteristics under axial loading of geopolymer concrete columns. So axial loading is improved by polymer confinement of geopolymer concrete columns after adding confinement materials like CFRP, basalt fiber sheets. Compressive strength and stiffness has been increased, and in the stress strain behavior, FRP has a significant impact on the stress-strain behavior of geopolymer concrete. So stress-strain behavior at low confinement levels resembles that of unconfined concrete. Then ductility. Although ductility is a crucial element of oil design structure, the most effective way to measure ductility is up for debate. Stiffness, energy dissipation, and displacement ductility factors are a few of the metrics used to assess column performance. Compressive behavior. The literature study demonstrates the major influence of polymer confinement methods on the axial loading behavior of geopolymer concrete columns. According to the experimental research, polymer confinement improves the column's mechanical characteristic, load deflection behavior, and failure resistance. Increased compressive strength that contribute to restricted columns improved performance. This results highlights the possibility of polymer confinement as a practical method to improve the structural performance and robustness of geopolymer concrete columns under axial loading. The behavior of geopolymer concrete column under axial loading, with and without polymer confinement has been thoroughly explored in earlier works, but now we are going to do a new activities. So for that we have to prepare our sample. And under the sample preparation, at first in first stage we have to select the material, and according to the mixed design we have to mix the material, and then I need to cast in the casting specimen, and then we have to compact, and after proper curing and after a span of time we can demolding and storage the specimen, and In this way we can get our sample. After getting the sample, we'll go through the test setup, and we will apply Excel loading for both geopolymer concrete columns for both confined and unconfined. And then we have to go through experimental testing. Geopolymer concrete columns will undergo axial loading test as a part of an experimental study to assess their behavior. The applied load will be gradually increased during the test until failure occurs. During the testing procedure, a number of metrics including load deflection response, failure mechanism, and stress-strain relationship will be monitored and recorded. And then we have to gather the data. The test related experimental data will be gathered and analyzed, and then we have to analyze the data using a statistical technique and the proper software tools. The acquired data will be examined. And for today, this is the end of my presentation. Thank you so much.